All right, ladies and gentlemen, today's class recording has started. As I mentioned to you guys before we started recording, this is going to be the first day of our next unit, and our next unit deals with our introduction to mechanics. And like it says up on the board, mechanics is the study of motion. There's two reasons why I like to start with this unit. First, the topics that we introduce in this unit, displacement, velocity, and acceleration, we will use those topics for the rest of the course when we're describing and explaining other things. So I like to get those topics down at the beginning because we will keep using them over and over and over again. And the second reason I like starting with this topic is because when we talk about the process of science, where do we start? What's the first thing we have to do? Ask a question. What is that question based on, though? What is our question? So our question is generally, our question is based on observation usually, right? We see something and we're like, hey, what's that all about, right? And we ask a question. Once we keep asking those questions, that's a good word, right? As we keep asking those questions and hopefully getting answers to those questions, now we start building what? Laws, facts, and theories, right? So, but those laws, facts, and theories started with the simplest questions. Like, hey, not that people, when they started asking these questions, asked this question. Nothing on my desk that I want to use right now. So if I take this book and I slide it across the table, what happens to it? It stops, right? Why does that book stop, right? That's a question that you could ask without any other knowledge of any other part of what we now call science, right? The questions that got asked to lead to the topics that we talk about here are questions that people, whatever, ancient Greece, or if we say that a lot of the ancient Greek knowledge and stuff like that came from China and whatever, right? There's lots of different, connections there, right? Whatever those questions were, these are questions that people asked a long, long time ago, all right? And so I like to start with those because in a lot of cases, they're the simplest questions. Because people in ancient Greece didn't know about subatomic particles and nuclear bombs and things like that. Right? It was just like, hey, why does this rock stop rolling when I throw it on the ground? Like that kind of stuff. Okay? So I will say this. Mechanics is a description of motion. Meaning, what is this unit all based off of? Well, yes. Okay, physics. Yes, that's true. If we talk about some of the terms that we introduced in the last unit, if we're just describing things in this unit, what are we going to be talking about? What part of science? Yes, well done, everybody. All right. If we think about laws, because laws describe things, right? What won't we be talking about? Theories, because theories explain stuff, right? Laws describe things, theories explain things. This unit is all about describing. We won't talk about explaining anything until next chapter. When we get into the next unit, then we'll talk about, okay, why do these things happen? But here it's just a lot of explanation, okay? All right, good there? Okay, so like it says, and I'll save that slide for there. When we talk about studying motion, a description of motion, what are some things that we would need to know in order to describe a motion? Example. Let's say that you're on your way home from school and you see a creepy clown guy walking down the street. Okay? Maybe, right? I'm not saying that's it, but if that's what happens, if that's what comes in your mind, go for it, all right? So, creepy clown guy walking down the street. You know your friend really, really, really doesn't like creepy clown guys, all right? So you want to call your friend and warn them about creepy clown guy. Okay? Not to be stereotypical, maybe it's creepy clown girl. All right? Girls can be creepy clowns as well. Usually it's guys, but let's not stereotype. Okay? So, all right. So if you're going to call your friend and warn them about creepy clown guy or girl, what are some things that your friend is probably going to want to know? Where is creepy clown guy or creepy clown girl? How fast is creepy clown guy or creepy clown girl walking? What we looking? Although your friend doesn't really care about how creepy it is, it's just a creepy clown guy. And so we don't really care about what that creepy clown guy looks like. Let's describe the motion, right? Does he have any weapons? Again, not a concern to your friend. Your friend isn't scared of creepy clown guys with weapons, just creepy clown guys in general, okay? All right. What direction is creepy clown guy going, right? Where is creepy clown guy? How fast are they going? What direction are they going? There's one more thing that they might want to know. Is that a hand or is that just, okay, so there's one more thing I'm thinking of that maybe they might want to know. Well, I mean, honestly, that doesn't matter. Where's creepy clown guy is the important thing, because then your friend can be wherever creepy clown guy is not, right? Again, if they know where creepy clown guy is, it doesn't really matter where your friend is, because they're going to get away from creepy clown guys, right? So where is creepy clown guy? How fast is he going? Which way is he going? Again, doesn't matter. Fat, creepy clown guys, skinny, creepy clown guys, doesn't matter. Your friend's all scared of all of us, right? Who he's after doesn't matter, because as far as your friend is concerned, he's after him, right? Okay? So what he's doing, right? That could be good. Or that could probably maybe be into how fast he's walking and which way he's going, right? Okay? There's one more thing I can maybe think of. Anybody want to take one last stab at it? That's not what I meant. Right? It's not what I meant. Maybe when you saw a creepy clown guy, right? Because that might be, what? Right, when he called you, right? So similar to that, warning your friend about creepy clown guy, there are certain questions that we want to answer when we are describing the motion of an object, right? And so, not to discount some of the things that other people said, when we're describing the motion of an object, what the object is doesn't matter. What we're talking about is its motion, right? So, there are 4 questions that we look to answer about a motion in order to describe it thoroughly. First, where is it? Second, what is it doing now? Third, what is it going to be doing, right? That's one thing we maybe didn't talk about. So if you say, hey, creepy clown guy is heading east on Hilliard, your friend might want to know, well, do you live east or west? Okay. That way or that way? East. Okay. Heading your way. So, right? So then the other thing you might want to know, okay, is creepy clown guy just strolling along, or is he running, right? That's something we might want to know, okay? And then finally, when? When do all these things happen? When was he in this position? When was he moving this fast? When was he moving this way? Those kind of things. If we can answer those 4 questions, we do a thorough job of describing the motion of an object, regardless of what that object is. Okay? Good? All right. So let's start at the beginning. Let's not talk about creepy clown guys anymore. Let's talk about this lizard. Okay? So let's say, right, you have a friend who took this class last year, and now they're in biology. Okay? And some of the biology teachers have animals in their room. Okay? And so your friend says, hey, my biology teacher has a chinchilla. And you go, that's cool. I like chinchillas. I want to go see it. So your friend goes, cool. It's in Mr. Owenhouse's room. Does that help you? No. Why not? You don't know who Mr. Owenhouse is, right? You don't know where his room is. right? So therefore, you don't know where the chinchilla is, okay? So what are some things that your friend would have to do in order to get you to the chinchilla? Tell us where his room is. But if he says, okay, Mr. Owenhouse's room is room C114, does that help you? Okay, so what would you, if say, oh, it's cool, Mr. Owenhouse's room is C114, what are you going to have to know in order to get there? Well, even if you didn't know exactly where C114 was, where C-wing is, right? You need to know that, right? But if your friend, right, was talking to one of their friends who lives in Canada, right? What else would they probably have to know in order to come see this awesome chinchilla? Where Ohio is, where is C-wing, right? C-wing is part of what? Westlake High School, right? So there's got to be some context there, all right? Describing where an object is called its position. But describing the position of something depends on a reference point. When we're describing where something is, we have to describe where we're discussing it is in relation to other things, right? If your friend calls you and says, hey, cool, I'm holding the chinchilla right now, that doesn't help you, because what don't you know? Where your friend is, right? Without a reference point, describing a position becomes very difficult. So the first thing we have to do is set the groundwork, okay? Set the scene of how we're going to describe where the chinchilla is, okay? Later on this year, okay, think about this maybe when you go along, okay? Later on this year, 9th grade, you guys are going to read Romeo and Juliet, okay?
Yeah.
So,
The
all right.
tragedy.
The tragedy of Romeo and Juliet, right? Does anybody know how Romeo and Juliet starts? True. Right. Families don't like each other. Okay. How do you know this, Lee? Did you read Romeo and Juliet last year? Okay. Do you know? Right. Does anybody know what the first thing of Romeo and Juliet is? You haven't read it yet, so I might not expect you to know, unless you literally like the first page. Yes, he tells you that, right? But there's a narrator, basically, right? And the narrator sets the scene, okay? He tells you where they are, Verona, by the way, okay? Tells you what's going on. There's these two families that kind of run the city, but they really hate each other, right? He tells you that they've been fighting, and eventually he tells you, spoiler alert, they're going to die, all right? But in order to understand the story, what do you have to know first? You have to know context, right? It doesn't make any sense. You don't understand why Romeo and Juliet can't love each other if you don't know that their families hate each other. Sorry if you don't know that that's Romeo and Juliet. Sorry to spoil the story for you, all right? But there's got to be some context. I can't get you to the chinchilla unless I have some context, okay? Now, that can become really difficult, providing context and describing where something is within that context. So for our purposes, we're going to simplify things. We are going to limit our study of motion to begin with to one dimension. Okay? We live in a three-dimensional world. What are the three dimensions that we deal with? Length, width, and height, right? So side to side, up and down, front and back. Okay? To start off with, we're only going to let things go in one dimension. What is one dimension? Side to side, which is just what? Length. So it's a straight line, right? If we're in a straight line, our options are limited. What can we do in a straight line? You can go that way or that way. Right? That's it. That's all you can do. So the context that we have to set in order to describe things becomes a lot easier because we don't have that many things to describe. We got to describe that way and we got to describe that way. Okay? So, what we use to be our reference point and the way we describe things in one dimension is basically a number line. Okay? You learned about number lines back in 2nd grade or whatever, right? What are some of the features of a number line? What's the most important point on a number line? 0, right? And then the numbers go in both directions, right? Numbers go this way and numbers go this way. How do we tell this way apart from that way? Some are positive and some are negative. That's what we're going to use. I saw it. So that's what we're going to use as our context of describing this motion. Right? So here was a lizard sitting on a rock. But describing that lizard's position is difficult if we don't have some context. So what do? We lay a meter stick down next to it. A meter stick has a 0 point, right? That's going to be our reference point. And then that meter stick, even though usually it only goes in one direction, we could set another meter stick down going the other way, and now we got 2 ways to work with. Yes? Okay. So where is this lizard? Now you could probably give me something a little better than that, right? Let's go here. Let's say, to make it a little easier to describe, let's describe the middle of this lizard. Okay? Where is that lizard? Between 20 and 30, right? Well, let's use our measurement skills and, what would be the measurement of this lizard? 25. Okay. So in this case, right, 20's known, 30's known, so our unknown digit's going to be the middle one, right? So let's say 25 centimeters. Is that enough to describe the location of that lizard? No. Why not? At least in terms of this picture, is that good enough to describe the location of this lizard? Is that the only spot that's 25 centimeters from our reference point? What if this lizard is 25 centimeters on this side of the reference point? Is that the same spot? No. So we got to distinguish one way from the other way. And we said one way we can do that on a number line is to use what? Negatives or positives, right? So the location of this lizard isn't 25 centimeters. It's actually positive 25 centimeters. Okay? One thing that we have to get in the habit of as we start doing this, okay? When we're talking about physics, when we're talking about mechanics and describing motion, the positives and the negatives, 1, are important, and 2, don't tell us anything about how big or small something is. The positives and negatives, when we're describing motion, mechanics, only tell us directions. They don't tell us anything about how big or small something is. Okay? Good there? All right. So what we've just done right here is described the position of an object. The separation between the object and some reference point. Okay? Good there? In order to do that, we needed to define what we call our frame of reference, or, like we said, the context in which we study motion. That's setting the scene for what I'm going to describe to you. It's the prologue of Romeo and Juliet. Right? It has to include 2 things. It has to include a reference point, but it also has to include a directional system. As far as the directional system goes, we could use like north and south or east and west, but when we have this picture of this lizard on this rock, do we know which way is north or south? We don't. But we can generally use that positive or negative to describe one way from the other way. Okay? Good so far. If we have a reference point and we have a directional system, we can describe the position of things all day long. It's real easy. Until this happens. Right? Until the lizard spawns a new lizard. No. Right? This is meant to signify that the lizard moving, right? Okay, when it moves. Okay? So now it's in a different position. We have to describe what happens, right? It was here, now it's there. So when we describe that movement, we look to describe the displacement of an object. The displacement of the object is defined as the change in position. The change in position relative to a reference point. Generally speaking, in order to figure out or describe the change in something, what do we need to know? Where it was, not where it will be, where it is, right? Where did it start and where did it finish? That's the change, okay? So let's take a look at this picture, which you guys have in your outline on the left-hand side there, okay? So here, the lizard started, and what would we describe as his initial position, according to this arrow right here?
Positive.
All right, positive 24 centimeters. Okay, let's go 24 just because it's definitely not 25, you know, whatever, right? Okay, good there? What would we describe as the final position of this lizard after his journey down this rock? Okay, positive 84, that's fine. That's good, because that'll make our math easier. So, okay. All right, so now let's talk about the change in position. First, we have this bracket up here at the top. Here's his starting point, here's his ending point. Okay? That notation is going to be an important notation. All right? Have we seen the triangle before?
Yes.
Delta, right? Let's go with the triangle in general, right? Anytime we put the triangle in front of something, first, the triangle is a Greek letter. It means change, yes. Triangle is a Greek letter. It's Greek letter delta. It's an uppercase delta. Greek letters come in upper and lower case, just like English letters. That's capital delta, okay? But anytime we put the delta in front of something, that means change. So in this case, we put the delta in front of the x. That means we're looking at the change in x. Why x? Well, if we have an object moving horizontally, that's just like the x-axis on a graph in math class, right? So this object is just moving along the x-axis. Here's the origin, here's the positive direction, there's the negative direction, okay? So here, this case, change in x. We're going to see delta over and over and over again. It's going to show up a bunch as we go along here, right? And we said that in order to calculate the change in something, we have to know two things. What do we have to know? Where it started, where it ends. When we're calculating the change in something, we always look at final minus initial. Where does it end up taking away where it started from? The difference is the change. Okay? So if we apply that to this down here, right? If we apply that concept to find delta x, we need to know where it ended up on the x-axis minus where it started on the x-axis. Does that make sense? So let's start plugging some numbers in. What did we say was the final position on the x-axis? Positive 84. So I'm just going to plug in positive 84 centimeters right in that spot of the equation. The negative, the minus, that's part of the math we have to do to figure out delta. That stays. It's not a direction, it's a mathematical operation. Okay? What was the initial position of this lizard before he started walking? Positive 24. Alright? You run that through your head calculator, and you find out that the displacement of this lizard's walk down the rock is what? Not just 60, positive 60 centimeters. Okay? Good so far? Okay. That's great until this happens. Okay? Alright, so this is still delta x. It's a different delta x, but it's delta x. It's the change in position. In order to calculate delta x, we need to know two things, right? What do we need to know? Where it was and where it is, right? X final minus x initial. Okay? What's the final position of this lizard after his walk down this rock? Positive 14, that works for me. Okay? Remember, the minus sign is not a direction, it's a mathematical operation. That stays. What was the initial position of this lizard before he started walking back? Okay? She did. That's okay. All right, when we do this math, what do we end up with? I'll help you. Negative 64 centimeters. Okay? Is it okay that it's negative? What did we say the positives and the negatives are used for when we're describing motion? Direction. Question, and I mentioned this to you before. This displacement is negative 64. This displacement was positive 60. Which trip is longer? This negative 64 is a longer trip than positive 60, even though one's positive and one's negative. Remember, the positives and negatives don't tell us anything about how big something is, just a direction. Okay? Displacement is our first example of a vector quantity. A vector quantity tells us two things. It tells us magnitude and direction. Magnitude is a fancy way of describing how much or how big something is. Direction is a fancy way of describing which way something goes. Hold on, 1 minute, promise. Okay. We're not going to go on the second page. I just want to review something real quick here. Okay. All right. So, got those things written down? Oh, that's not what I wanted. What is the magnitude of this displacement? What is the magnitude? 64 centimeters. The direction is what? Negative, right? Vector quantities have to describe two things for us. They have to describe how big something is, but also which way it goes. Okay? Good there? Yeah. All right. Tomorrow, we will talk about displacement and compare it to something else called distance traveled. We'll talk about how those are similar, how those are different. Then we'll also get into speed and velocity and how those are similar and how those are different. Okay? Good there? Don't forget, there's a couple pages from your book I want you to read tonight, reinforcing some of the stuff we talked about today in class. We'll get into some more stuff tomorrow.